Hello students, welcome to this particular session. Here in this session we will discuss the mirror formula. I think theoretically we have already discussed. So in this particular session what we are going to do is we are going to mathematically verify the mirror formula, right? And mirror formula, as you are aware, it's a relationship between the object distance, the image distance and the focal length of a mirror. Notation wise, object distance, which is to be measured from the pole of the mirror, it's represented by U. Image distance, which again is to be measured from the pole of the mirror, we will represent it by V. And focal length of a mirror, obviously we will represent it by F, right? So we will derive this formula 1 by V plus 1 by U equals to 1 by F. This is known as mirror formula. And in this session only we will also verify that linear magnification, which I am sure you are already aware of. We have done it in the previous lecture. It is actually the ratio of the size of the image to the size of the object. And in terms of image and object distance, it is given by n equals to minus b by u. So this is the formula which again we are going to prove right now in this particular session. And this mirror formula is valid for each and every type of mirror and for every position of the object, whether the nature of the image obtained is real or virtual, whether we are considering concave mirror or convex mirror, these formulas remain valid. So what we will do is, concave mirror, you are aware, the nature of the image obtained can be real as well as virtual. It can be virtual only in one case, when the object is placed between the pole and the focus. For rest of all the positions of the object, the nature of the image obtained in the case of concave mirror is always real and inverted, right? So in dealing with concave mirror, we have to consider both the cases, when the nature of the image obtained is real as well as when it is virtual. So let's consider the first case. We are deriving this particular formula in the case of a concave mirror when the image is real. For obtaining a real image, the object is to be placed beyond the focus in front of a concave mirror, right? So let's do it. Let's draw the ray diagram first. This is a concave mirror. As you all are aware, it's a mirror, it's a part of a hollow sphere and its reflecting surface is towards the center of the hollow sphere of which it forms a part. The center of the spherical mirror is known as pole. The line joining pole and the center of curvature, that's principal axis. Exactly the central point between P and C, that's the focus, right? So when the image is real, so it's your wish, students, you can place the object anywhere beyond F, at C, beyond C, at far away distance. But in order to obtain real image, the object is to be placed beyond F. That is the key, right? Let us assume the object is placed over here. Suppose this is the object placed over here. AB is the object. So I have told you about the 4 rules of the image formation. So let's make use of those rules. Incident ray from the object which is parallel to the principal axis, after reflection it will pass through the focus, right? This is the first rule. You all are aware of it. Second rule is, when incident ray from the object is incident at the pole, it will obviously bounce back into the same medium, obeying the laws of reflection. So it will bounce back into the same medium like this. This will be the angle of incidence. This will be the angle of reflection. So this is where the 2 reflected rays meet. So here the image will be formed, right? As you can see, if the object is like this, its inverted image will be formed like this, right? So this is where the line is to be drawn. So it will become upside down. That is, inverted image will be obtained. This is A dash and this is B dash. Those are perpendicular, right? So we have discussed all these cases earlier as well. So obviously, in this case, enlarged image is obtained beyond C, image is magnified. It is real and inverted, right? Okay. In order to to verify this formula, what to do is, suppose this point is C. And you can drop a perpendicular from here. You can drop a perpendicular like this and consider it to be N. Now look, as I've told you, this is extremely a small part of a hollow sphere, big hollow sphere. So the aperture of the spherical mirror is too small, it's very, very small. So point C lies very close to point P, right? So if you draw a perpendicular, then points N and P would lie infinitesimally close to each other. That is, while doing the mathematical operations, we can consider point P and point N to be coincident, to be lying vanishingly close to each other. So these 2 points may be considered to be coincident with each other, right? This is the logical approximation which we'll make in deriving this particular relationship. So let's proceed. First and foremost, we need to consider 2 pair of triangles, right? Consider triangle A dash F B dash, A dash F B dash, and triangle CFB. CFB. I've asked you to consider these 2 triangles. Look, I've asked you to consider this 2 triangles. A dash F B dash and CFB. Now look, this angle is equal to this angle, vertically opposite angle. This angle and this angle, each is 90 degrees. So these 2 triangles are similar by AA corollary, right? These 2 triangles are similar. Triangle A dash F B dash is similar to triangle CFB. No doubt regarding this. Now whenever the 2 triangles are similar, then their corresponding sides are proportional. We'll make use of this fact, right? So what you consider is, you consider these 2 triangles, this one and this one. These 2 angles are equal and these 2 angles are also equal. Therefore, by A corollary, these 2 triangles are similar. Therefore, their corresponding sides must be proportional. So, let's consider A dash B dash. In this triangle, let's consider this side A dash B dash. What is the corresponding side in the other triangle? This is the other triangle. So, its corresponding side is CN. CN. Or it can be considered to be CP because N and P are coinciding. So, it can be considered to be CP. Right? A dash B dash divided by CP. These are the 2 corresponding sides. It's equal to FB dash. We are considering the base. In this triangle, we are considering FB dash. So in the other triangle, the corresponding side would be PF. It should be written as NF. But since N and P are vanishingly close to each other, so NF is approximately equal to PF. Put this as equation 1. So what we have done over here is, these 2 triangles are similar. Therefore, their corresponding sides are proportional. That is, A dash B dash divided by this side would be equal to FB dash divided by this side. This is what we have done. Right? Now you need to consider other pair of triangles. Okay. For this, we can consider these 2 triangles. Consider these 2 triangles. For your benefit, I am shading these 2 triangles. That is, consider triangle APB and consider triangle A dash PB dash. Now observe these 2 triangles. These 2 angles are equal. This is 90 degrees, this is also 90 degrees. So again, by A corollary, these 2 triangles are also similar. Therefore, again their corresponding sides are proportional, right? So, A dash B dash, corresponding side over here is AB. And AB, it's equal to CP. AB, it is parallel. So, the perpendicular distance between 2 parallel lines is same. So, AB is equal to CP. That is what I have written over here. Here, we have to ensure that the left hand side should be equal, right? It is equal to, now consider this base. Base of the big triangle is PB dash. While on the other hand, the other triangle, the smaller one, its corresponding side would be PB. Clear? So these 2 shaded triangles are also similar. Therefore, their corresponding sides must be proportional. A dash B dash divided by AB, it must be equal to PB dash divided by PB. That is what I have written. And AB naturally is equal to CP. And the point to be noted is that these two equations should have the same terms on the left hand side, so that we can equate these two. The right hand side terms may be equated, right? So please ensure the terms which are the left hand side of equation 1 and 2 must be same. So accordingly you need to choose the two triangles judiciously. Pair of triangles needs to be chosen judiciously, right? Okay, let's proceed further. From 1 and 2, since the left hand side are equal, therefore what we get is FB dash divided by PF is equal to PB dash divided by P. Now students, do you remember the sign convention, the first point which I mentioned? All the distances are to be measured from the pole of the mirror. P should be the initial letter. So there is no problem in these three terms. P is the initial letter. But here it's FB dash. So now my job would be to convert FB dash in terms of P. Like FB dash. Now look, this is FB dash. It may be written as PB dash minus PF. Isn't it? FB dash may be written as PB dash minus PF. So FB dash can be written as PB dash minus PF divided by PF is equal to PB dash divided by P. Now all the terms has initial letter P. Now we can make use of sign convention. So using sign convention, what we get is, I have told you all the distances measured from the pole along the direction of the incident ray is to be taken as positive, while distances measured from the pole of the mirror against the direction of the incident ray, that is to be taken as negative. This is the direction of the incident ray. So all the distances are measured from the pole in a direction opposite to that of the incident ray. So all are negative. So focal length of a concave mirror, you all are aware it's negative. P, B, that's the object distance, again negative. PB dash, real image is obtained. The distance of the real image in case of mirror is always negative. Look, incident ray is traveling from left to right. PB dash is measured from right to left. So it is minus P, right? So let's substitute all these values over here. We should get this expression. So what we get is PB dash minus U, PF minus F, minus 1, so it will become plus. It is PB dash, that is minus B, PB minus U. So minus minus get cancelled. So minus U plus F is equal to V by U. Just cross multiply it and let's check what you obtain. So what we get is, this is the expression, isn't it? So let's cross check it. So we will obtain minus U plus F into U is equal to minus VF. Right? Actually, this is PB dash. PB dash should be minus V over here. So place minus V. Okay. Now let's solve it. What we get is minus UV plus UF is equal to minus VF. Now you can rearrange these terms, right? Let's make the terms positive. So bring VF from right hand side to left hand side. We'll get VF. And UF is left plus UF. It is equal to UV. This term can be taken in the right hand side, so it will become positive. It's okay. Again I am repeating. After this, when all the terms have initial letter P, you need to apply sign convention. And here incident ray is traveling from left to right. And here from pole all the distances are measured from right to left. That is in a direction opposite to that of the incident ray. So all are to be taken as negative. PB dash, it's minus V. PF, it's minus F. Minus minus, it will become plus F. PF, it's minus F. PB dash, it's minus V. PB, it's minus U. right? Minus minus get cancelled, we'll be left with this and simply cross multiply it. Clear? So we'll obtain this. And in the last step, what you need to do is divide throughout by UVF. So let's see. VF divided by UVF plus UF divided by UVF is equal to UV divided by UVF. What I've done is divide on both the sides throughout by UVF. So what is left is 1 by U plus 1 by V is equal to 1 by F. So that's the mirror formula for you. So mirror formula is a relationship between the object distance, image distance and the focal length of a mirror, right? So you need to choose two pair of triangles. You need to prove that they are similar and then the corresponding sides are proportional. Ensure that the left hand side of these two equations must be same so that you can equate the terms on the right hand side. And thereafter also you need to ensure that all the terms must start with letter P because distances are to be measured from the pole of the mirror. And in the last step, make use of sign convention. And thereafter just you need to solve it mathematically and in the last step, divided by UVF, you will arrive at the result, right? We need to discuss another very important formula which is for the linear magnification. In terms of image and object distance, we are going to prove this. M is equal to minus V by U. Let's do it. You need not to do any expression again. Let's consider the same ray diagram which has already been drawn. Okay, let's consider equation 2. From equation 2. So what do you get? A dash B dash divided by AB is equal to PB dash divided by PB, right? This is the equation. Now as you are aware, the erect image, the size of the erect image is always taken as positive. Do you remember that? The distance is measured perpendicular to the principal axis and in the upward direction that's positive. And the distance is measured perpendicular to the principal axis and in the downward direction that's taken to be negative. So over here, what we'll do is, let's make use of sign convention directly. A dash B dash, it's inverted. So it is minus H2. H2 is the size of the image. It is size of the image. And negative sign suggests that the image obtained is inverted. What about AB? It is H1. It is erect. So positive sign. So it is H1 is size of the object. What about PB dash? PB dash. It's the image distance from the pole which is negative, just now we have discussed. PB, object distance, object is placed always in front of the mirror. It is always real, so it is always negative. In the case of mirrors, the real distances are always negative. Virtual distance, they are always positive. So let's substitute these values over here. What do you get is A dash B dash, it is minus H2. AB, it is H1. PB dash, it's minus V. PB, it's minus U. We can write it as H2 by H1 is equal to minus V by U. Right? Minus minus get cancelled, this minus sign goes over there, we are left with this. And we know that linear magnification, it's defined as ratio of the size of the image to the size of the object. Therefore, it is equal to minus V by U. So this is the mathematical verification of this particular formula. That is M is equal to H2 by H1, which in turn is equal to minus V by U. So this mathematical verification is important from senior class point of view. For 10th class point of view, it is not in your CBSE syllabus. But still I will recommend, you need to understand from where the formula has come. So you need to appreciate the derivation part as well, right? So I'll suggest all the students to go through this derivation, right? This is very simple, you can easily do it. So we have derived the mirror formula for concave mirror when the image is real. In the next session, we will consider when the image is virtual and then for convex mirror.